And welcome to the second webinar in the FXCM webinar series on algorithmic trading. I'm Yves, I'm founder and managing partner of the Python Quant, and I'm really excited for this webinar series. Today we're going to cover the, let's say, preview version of the FXCM RESTful API. What I'm going to show is not yet available to the general public, so to say, to interested traders. But nevertheless, this will come out soon. Therefore, watch out for what is on the horizon. It's not too far away anymore. And without further ado, I would like to jump right into a little slide deck that I've prepared for the introduction. And later on, I will, of course, have a live demo. There is disclaimer as usual. Please read it carefully. At this point, I will post the link to my slide deck to the chat. So please have a look. So you can access the information. And once again, please have a look for the risk disclaimer because it's important information. With regard to the agenda, maybe we have some new participants today in the webinar, so I will have a quick run through what we are doing. I will keep this really short. I will then dive into machine learning and algorithmic trading, what the parallels are, and how algorithmic trading or trading in general can benefit from what is going on the machine learning side. I will then quickly recall why we use Python for algorithmic trading, and will match this also against what we are up for with regard to the FXCM RESTful API. The live demo then will cover basically 5 points. The first is the connection to the FXCM RESTful API is a very brief part just to show how it works. Then retrieving and working with historical data, important for every kind of, let's say, backtesting exercise or other analytics tasks. Then I will even show a little machine learning example for market prediction and what might lie into such approaches for even the retail algorithmic trader, let's say. I will also show how to retrieve and visualizing streaming data, because once you get started with automatic algorithmic trading, you need to be able to digest real-time data and also probably to visualize this. And last but not least, it will be about placing orders via the RESTful API. This will just cover the basics. In the third webinar, we will then show, let's say, an integrated example which combines the single elements that I'm introducing today to a single strategy from A to Z, so to say. Python Quant group, we are basically active, as our name says, in the financial industry using Python and other open source technology. Our core is training. You find all the information under tpq.io. So once you get access to the slides, you have the links to everything else. Myself, if you are wondering how I look like, this is me in action giving a talk about blockchain. You see all the hash codes in the backend, and many resources are also available under hillfish.com. Our flagship product, if you like, is the University Certificate in Python for Algorithmic Trading. This covers quite a bit of ground. It's really comprehensive. You see 125 hours of pre-recorded video instruction, and many of the topics that I will touch upon today are also taught in a little bit more detail, of course, there in the program. You see 1,200 pages of material, 5,000 lines of code, and growing and growing. So we're trying to add more and more. So this is what we are, I think, really known for in the market. But let me come to our major topic today, driving forces and algorithmic trading. This is a slide I've used previously, and I want to go into a little bit more detail because it's kind of amazing how strong the parallels are between what's happening in machine and deep learning and what is happening in algorithmic trading. So both disciplines actually must rely to some extent on data, on algorithms and hardware. Algorithms could be replaced by software. I mean, in the end, it's software that is kind of the technical representation of a certain algorithm. But I like to put it here as algorithm because we are talking about algorithmic trading. Then in the middle part, you have something like optimization, training, learning, testing, validation. The goals might differ in to some extent. So let's say in a machine and deep learning area, they might be interested in building a self-driving car. In algorithmic trading, it is different, but not too different, in the sense that we can make use of everything that is happening in the other areas. So trading, algorithmic trading, let's say, is a discipline that looks after the creation of a money-making machine, and the machine should do this on its own. So preferably without human intervention. So there might be some human being who set everything up, but afterwards it should run on its own, so to say. Against this background, what is the basic approach of machine learning? Machine learning tries to a large extent to replicate what human brains are capable of. So whenever we have some input, we can use our brain to process this input and come up with some output. So classical examples in this regard are, for example, I see an image, I identify a cat on the image, and I say, well, have a look at this nice picture with a cat on it. So machine learning algorithms might try to do the same. So being fed some pictures in electronic form, of course, there might be an algorithm that is able to identify a cat in such a picture. But there are many, many other applications. We ourselves are probably exposed to many such applications on a daily basis. So whenever you log into Amazon or Netflix or Spotify or any other kind of platform, there are machine learning algorithms in the background that do recommendations, that do sorting for you, that with Google, that come up with the most appropriate results given your search history and all these things. So we are exposed to this already on a daily basis. And when we have a look at how history has evolved, here's a famous quote from Albert Einstein: "The grand aim of science is to cover the greatest number of experimental facts by logical deduction from the smallest number of hypotheses or axioms." So we can translate this easily to our discipline of trading, where we say, well, we see many, many things in the markets, but if we can identify things that happen over and over again, we might come up with a hypothesis, with kind of a, let's say, a technical indicator for this, we might be able to trade on this. But machine learning now is kind of, and this is what influences algorithmic trading considerably, is a scientific method on steroids. So it follows the same process, so it's similar to what a brain, a human being, would do. But we all know we have just limited capacity. 24 hours, we have our brain, and this might process only that much information. But a machine learning system can do the same thing that we might take weeks or months in a second. This can be scaled to previously not possible scales, even for the retail trade. And this is the fantastic thing, is not only that the Googles in the world, the Facebooks in the world are able to access the fascinating technology I'm talking about here, is that it's basically available also to the single trader, or let's say smaller entities in a broader sense. So this is one of the major charts that I use previously when I'm giving talks and so forth. It is when we have a look back. So of course we have financial markets, and there is news, some information. X can be some large blob of data, or a smaller thing where we say, well, there is some news, let's say earnings announcement, which might be interpreted as a surprise, and we see kind of an influence on the price of the respective stock. In the finance history, it was mostly about, I like to call it the genius brains, that came up with some wonderful, elegant mathematical theory and formula, and said, well, I've derived this elegant thing, like in the sense of Einstein's quote, using just a few axioms, and have come up with, let's say, the CAPM, or the portfolio theory, or arbitrage price theory, or whatever theory comes to mind here. But the problem mostly was that the elegant theory didn't fit pretty well with the market. So f of x not equal y. So elegant theory, but not really working in the markets. And this is what I call brain-driven. Somebody sits down, does math, and comes up with some elegant theory, but unfortunately, more often than not, it didn't work pretty well in the markets. AI in finance puts this upside down, or brings it back to the scientific method, in that sense that the data is first. So we're talking here about dataism, or with the term already introduced, machine learning. We have parameterizable models, and the models simply get fit to what the data says. So basically, we don't need the geniuses anymore if the machine does the work here. So AI replaces the brain of the genius financial researcher, so to say, and this is all data-driven. This takes into account that things might change over time. So when the CAPM was devised, for example, in the 60s, it was the CAPM, period. There have been some refinements, some generalizations, but basically it's a CAPM. Here, this view, data-driven, simply says, well, this can change over time. So I could have even put here a time subscript. This is what is called data-driven, and this is what machine learning brings to our training field. In that sense, when we apply machine learning to the markets and agents acting in the markets, so it's not the brain that we want to simulate, that we want to learn something about how it works. It's simply that we try to replace what is happening in the markets, how the single individuals process data, that is replaced by algorithms. So this is basically the approach in a very simplified manner visualized here. After this little introduction and explanation why I think that machine learning is so important for our field, a quick review and recap why Python, because everything that I will show later on will all be about Python, based on Python. Python's benefits are numerous. I focused here on 10. It's open source, general purpose, multi-paradigm. I think one of the major reasons for us in finance to use Python is the powerful ecosystem, number 4. But also that it's leading in data science and a first-class citizen in AI. If we want to make use of machine learning, of course, we must use the right technology to get our hands on the fantastic tools that are out there, algorithms and packages. It's also a core technology in finance, so whenever you have a look around what people are offering these days in terms of wrappers for their APIs or core technologies that they use, it is most often Python. That is maybe among others, but still there. Books and resources, many things are there. And this is kind of a quick run through the benefits of using Python. When we want to apply machine learning to algorithmic trading, we can say both disciplines need access to lots of historical and granular data sets. And I've used this slide, but adjusted it for today or previously. So here you see that I'm now matching what I'm going to show. In the first webinar, we had FXCM tick data. Today, we will use the FXCM RESTful API, which is a little bit more flexible, has a modern approach. And also access, of course, to real time, which is also called streaming data via sockets, because we simply, when we want to trade in real time, we need to have data in real time. It doesn't really help when we want to do a real-time trade based on some signal generation, but we just have data from yesterday. So therefore, current data for our, as it's called in computer science, online algorithm. Online meaning that we are just on the edge of the data stream, in the sense of that we are always working with the latest available information. Also powerful hard and software to work with. I think here the barriers of entry have come pretty low recently. So the Python ecosystem is, I think, almost without any exception, open source. So there's not a big deal to get the latest and greatest there. Cloud compute and storage has also come down considerably in terms of cost, and power has increased at the same time. So you can get started with a professional cloud instance, let's say for $5 per month. So I would consider this to be a really low barrier of entry when we talk here about making money by algorithmic trading. So I think everything is together to get started, and in particular with the new offerings with FXCM, every ambitious algorithmic trader should be well equipped either to get started or to implement strategies that have been used in different places before in a professional environment. So in the first webinar, I just covered 3 parts here. Financial data, strategy, a little bit of backtesting. Today we will add to the mix connecting code and also trading code. Trading code, for example, is the ability to place orders, to initiate a trade. So otherwise, algorithmic trading wouldn't be that meaningful if I'm not able to trade programmatically. And in that sense, we have covered the core of our pyramids that we typically use to illustrate algorithmic trading. And in the third webinar, we will then also touch upon a little bit of the two other areas like infrastructure and automation. A quick review how we can apply machine learning to stock market prediction. I start with some general remarks. So here I try to visualize how a recommender engine works. Recommending here, my example, I'm using here an Amazon example, one of the first well-known examples in this regard, where, for example, the case might be that a new book comes to the market, and this book has been sold, has been bought by a bunch of people. And Amazon has, of course, a history of the other books that these people have been buying. So here we have person A to person D. And person A bought only book 2 and 3, person B book 1 and 3, and person C just book 2, and person D book 1 and 3, so the same as person B. In this case, you see that person B also bought the new book and person D didn't buy the new book, and in the other case, so you see kind of a pattern here. So 0, 1, 1, 1, 0, 1 looks like binary digits, binary numbers. But the basic idea of machine learning is that Amazon uses machine learning algorithms to digest all the historical information of the customers, in this case, of these people, and now tries to predict for a person who hasn't bought the new book whether this person might be interested or not. So let's say there is person E now, and person E has bought book 1 and book 2. So Amazon now has the problem whether to recommend the new book or not. And this is what is about machine learning. And this can be translated. I just decided for Amazon, this could have been Netflix or Amazon Prime, where we talk about video, or this could have been Spotify for music, or this could have been Audible for audiobooks, or any other, let's say, media platform or shop, for example. So that's the basic idea. And this is done on large scales in that many different application scenarios on a daily basis. I don't have any numbers, but this is a really large-scale business, what I'm talking about here. And in machine learning terms, we speak here of supervised learning because we provide the input as well as the output. And the machine tries to come up with an algorithm that, based on the inputs, is then able to replicate the outputs and even to get some output when there is new input. So that's the basic idea. It's similar to regression. And it's also called classification, yes, no, or category 0 and 1. And now let me transform this to the trading. So pattern recognition to chart this way. You see on the left side, you see a couple of typical structures, and this is courtesy of the internet. I don't know the source anymore. Descending triangles, ascending triangles, head and shoulders, rectangles, and all these structures that people have the lookout for, where they say, well, in this case, probably I go short here, I want to go long, and sidewards trending or whatnot. So this is basically what chartists do since decades, we can say. But on the other hand, I have here a quote from a nice book, Technological Singularity: Artificial Intelligence Beneficial in any domain where patterns have to be found in large quantities of data, and effective decisions have to be taken on the basis of those patterns, especially when the decisions have to be taken rapidly. And I think this perfectly fits our description here. So looking for patterns, and once we have identified a pattern, then also to act decisively and quickly based on what we have discovered. So now often the idea is that we as human beings need to feed the patterns into a machine. But let's say one of the benefits of machine learning is that we don't even need to feed the patterns into the machine. The pattern discovery is something that the machine will also take care of. This is a fantastic thing. So we don't need to say to the machine, well, there are ascending triangles and need to program this. No, if there is something if there's some value in such an information, then the machine probably, hopefully, will recognize it. Coming to a trading context. So here I have a previous data. So this is end of day data for the Euro-US dollar exchange rate from the FXCM API. And you see above here the exchange rate on a daily basis, and you see the returns in green. But what we are basically interested in when we trade in general is not really the absolute level here, nor the absolute value of the return. What we're interested in here is the third subplot, basically whether the market goes up or down. I mean, it would be nice to know exactly how much it will go up, or to know exactly how much it will go down, but this is even a harder problem. If we can solve the problem with some degree of precision of predicting the direction, then we are well off. So this is kind of like going in the casino and playing roulette and knowing with some edge whether red or black will turn up. So, and this is what we are after. And translated to the previous context here, this means knowing 0 or 1. And I will now show how to translate this. So this just as my frame of reference. Here you see now real data. This is data, once again, that I have calculated based on end of day data from the FXCM API. So it's rather recent, 9th, 8th, 7th, and 6th of November. So basically last week. And you see the returns in the daily rate. This is indeed in percent. So here it's a fifth of a percentage point that we are talking about. So we need to read this carefully. So 0.19% was the movement on the 9th of 11th from the 8th. And we now translate here the problem of the return prediction into a setup which is similar to my Amazon example. And you see here I have the returns, and here I have the 3 most recent lags. So for example, this is the day before the 9th, therefore lag 1 is exactly the same as here. Lag 2 is 2 days before the 9th, this is down here, and here in lag 3 I find this value. So the trailing numbers here in terms of lags, as we call it, are now on the left here in my little example for the return. So I would use these 3 returns and try to predict the return on this day. Of course, the real problem is when I want to go beyond my data set and want to predict the value for the 10th, 11th, or now going into the future, today having the 14th, when I want to predict the return for the 15th. But first we should simplify the story in the sense of that, I said it before, we are basically interested in just whether the market goes up or down. If we solve this problem, well, we can be proud of ourselves. So you see here the pluses and the minuses that replace now the numbers. So I'm losing information in terms of how big the movement was in absolute values, but for the time being, I want to restrict myself to market direction. And here you see, for the machine to be able to digest this, I would then put it into the same framework as I used for Amazon. So I would have 0s and 1s, indicating 0 might be a negative return, or 1 here a positive return. And now I'm back in the game, and I have translated my stock market prediction problem to one that a machine learning algorithm can easily digest and can work with. This can all be made much more granular, better, and so forth, but I first want to introduce this basic setting. We will apply this very approach later on to the data that we have. There's a question, a technical one, what feature stands for. So here I changed feature now, you see, from my previous slide, from lag. This is, and I'm coming here, lag 1 is the return from the day 1 day before the return I'm interested in. So this is here the one that I try to predict, and the previous return is lag 1, and this then turns into feature 3. So numbering or ABC or lag 1, 3, this in the end doesn't really matter, but this would be, in that case, in my case, would be the leg 1, this would leg 2, and this will be leg 3. So these are just the previous returns. Machine learning for algo trading, I think, has the following advantages. It allows for automatic pattern discovery. So we don't need to believe in something, don't need to formalize it for the machine. We just let the machine look for something worthy. So where we say, well, whenever we see this pattern, we expect the market to go up. So of course, probabilities and stuff like that are involved. Then the machine might discover patterns humans have never thought of. So of course, there is a little bit of a history. There is, let's say, a culture, and there is common sense, common knowledge, as they call it, among traders, where they say, well, let's pick out one of the most famous one, Head and Shoulders proved to be blah, blah, blah. So this is something that is in the human brain and that you might learn, but maybe the machine discovers something humans have never thought of. So this might be a real benefit here. It's also, and foremost, easy to scale, and you can work here with huge amounts of data and configuration. So basically, it doesn't matter whether you check this for one instrument working with end of day data or for 500 instruments working with tick data. So the machine, if it's powerful enough, doesn't have an issue. Maybe it takes a little bit longer, of course, but this is not the real issue. And it does not need too much human intervention. So you just let it run and see what's coming up. Just let it run might sound a little bit too simplistic, but basically it's not too much what I wrote here. There's another question. Yes, indeed. Leg 1 is 1 day before, leg 2 is 2 days before. I will have an example explicitly showing this based on real data once again. Then I hope it will be clear. Now I'm at the point where I would start the live demo. Once again, the agenda, the connection, then data retrieval, then my little machine learning example based on support vector machines, retrieving and visualizing streaming data, always one of my favorite parts, and placing orders via the FXCM RESTful API. So here, I will just focus on the technical side of things, not on the question whether this trade now makes sense or not. So I would just show how to make it technically, programmatically by using our wrapper and the RESTful API of FXCM, and not that much in terms of, is this a good trade or not, or what is your expectation? So it's all about technology, if you like, in this regard. I'm now changing here to my little notebook. Actually, it's not too little. We have quite a few things in here. Also here, the risk disclaimer. Once again, please have a careful look here. So connecting to the RESTful API, you might wonder maybe what I'm using. So in terms of architecture, the RESTful API is something that is run on FXCM servers and which allows you to access the functionality that you might be using maybe even for a long time via different applications, like on your iPad or via the web browser. And this now gives you access to all the functionality via such a program environment. If you are curious, let me quickly just open just a wrapper. So I cannot share this yet, but here you see this is the Python class which we have written around this. It's a little bit of code, so I don't want to go into any detail here. When I go down, you see this might be, I don't know the latest number, so it's growing and gets changed. So we have 2,200 lines of code. And this, if you like, is the basic infrastructure which allows you to do algorithmic trading via the new API. This just to give you a feel for it. This will be available later on as open source as well. So let me import this file that I've just shown and let me instantiate a connection object. This might take a little bit. And basically what you see here, that's the reason why I've left it here but commented out. In order to get a connection, you need an access token. Here, this is the dummy access token that I've put in here. But basically, when you have an account with FXCM, you will get an access token that you can get in your account settings. And you need to use this token to connect. Then you have two more options with regard to a lock level and lock file. So this is more from a technical point of view. But basically, this is your key. This is the token that you need to get connected. This is happening here all in the background. Once we have this connection object, I can check, for example, whether we are indeed connected. So here too, fortunately, we are connected. My account just has one single account ID, and when I'm speaking here of my account, this is the demo account. So everything that I'm going to do is unfortunately based on paper money, so no real money involved for what I'm going to do. So as one of, let's say, simple but useful applications, you can here call the method getInstruments, and you get technically a Python list with all the instruments you have access to. So for example, say you want to get historical data for US oil. You see, oh, well, here is US oil. Or my running example, one of my running examples would be US dollar, Japanese yen, as well as euro, US dollar. So the first two that we have here. When I want to check whether there are active orders, there are none. So later on, this will change. But here in the beginning, I just wanted to show that we don't have any active order in the demo account. Let me proceed to the first real application in terms of retrieving and working with data. So the focus here is on retrieving. I won't do that much work with it apart from visualization. So first, what we need here is the offer ID. So this might be something, for example, that changes. So some things that I might show here might be changed in the version that we are going to publish later on, or that FXCM decides to publish. So still some development is done, but I think that the basic infrastructure, the backbone and everything around it is there. So in that sense, having said that, I use offer ID here, define the period, 1 day and number 10. So this, I would expect, gives me the 10 most recent days and daily data. And you see this is kind of fast. And I now have this Python data frame object, pandas data frame object with bit open, bit close, bit high, bit low, ask open, ask close, ask high, ask low, and the tick quantity also. So see here more active days and less active days. But there are many more parameters that can be used in combination with the API, so we're not constrained, thankfully, to daily data. I think one of the most popular time intervals used for trading is the 1 minute bar. And here I'm now retrieving, it says 50, so I should have this consistent, 50 most recent 1 minute bars. And I print out just the last 10. And you see this is kind of current. This is in GMT time. I'm here CET time, so we are 1 hour ahead. This is 1:36, so I get the last minute or the data already here via the API from the previous minute, so to say. This is really, really convenient and let's say close to the market and to the needs of the algorithmic trader. Of course, we can work with other instruments, we can work with other periods, we can retrieve more data, less data. All the flexibility is there. But let us work a little bit with the data. So the first is a very simple application. Oh, there's a little bit of action going on here in the market, as we can see. The exchange rate is on the rise. And you see that I've just picked out one column out of the 9, I think, that I have here. Yeah, 4, 4, 1 is 9. And I'm just plotting ask close on a minute bar level. So it's a single line of code once we have the data in there, and you see how efficient this all is. There is a question now with regard to whether I'm using tick or time-based bars. I'm not really sure if I understand this correctly, but here I'm working with 1 minute bar. So the API provides me with 1 minute bars. There is, at this level where I'm now working, there is no tick data involved, so to say. Whenever we have a new 1 minute bar full, if you like, I get the next one. So maybe let me try and see. There you see now this has increased. 37, so 36 are now available as well. So when I was talking, the data set available to me has become more current, more recent, so to say. There's another question with regard to whether to use range bars. The API currently supports here the minute intervals, 1, 5, 15, 30, 1 hour, 2 hour, 3, 4, 6, 8, and 1 day, 1 week, or 1 month. This is what the API currently supports, and you see it here in the text that I'm highlighting now. And when you mean by range bars, ranges with start and end date, this will also be available in the API. So here I'm transforming my data set just a little bit. I'm picking out 4 columns out of the 9, do a little bit of a renaming, and something I've introduced recently, namely cufflinks and plotly plotting, now gives me a candlestick plot here, going here in you see it in GMT time for 12, and you see here everything on the rise. So interactively, I can zoom in and out once again, kind of really nice. If I now want to start, this is something I have shown in the first webinar with some technical analysis, so be it. We add here as a little example, Bollinger Bands. We don't have that much data, so you now see here how this looks. We have the SMA 10 and the upper and lower band here represented by our standard deviation by a factor. So I think pretty nice and also straightforward. You see, this is all what I do is usually I'm talking much more than the code that's much longer what I'm saying than the code that I need in order to get this accomplished. But let me now move on towards machine learning, because I thought it would be nice to support what I was pointing out before by a live example. And now this is indeed live, so I don't know what the outcome will be because the data set is changing. I have a fixed example as well, but let me simply try it. Oh, there's a question. Yeah, this was let's say clarification with regard to range bars for 5 points. I think not by default, but this might be something you would be able to do via or on your own. I would assume kind of easily by using Python in combination with tick data. So of course, such an API in a standard fashion just provides you with certain, let's say, presets, defaults. I think we have quite a bit already implemented, in particular the API team of FXCM. But I think what is not there can also be easily added if you have individual requirements by the use of Python and respective raw data, so to say. So here, moving to my example. For the example, I'm retrieving a little bit more data. It's it's far away from big data, but to have some meaningful data set, I'm now, and you see it's growing. So as I speak, we get new data, and I'm using here 400 of the previous minute bar data rows that we get. Here I'm transforming this, and this is now the base data set. So 400 minutes back, and you see here it's on the rise, it's on the rise. This just to show you the data set I'm working with. So now the next step, this is now starting to apply machine learning. You remember my example with 3 lags and so forth, and this is now the point where I calculate the returns. And I'm working here with 6 lags, and here I'm doing the lag. So a little bit skipping over the details, I just want to show you the data set. Maybe first the hat might be nice. When I show you the hat, and you see here that we have this triangular structure. And this is the first time where I have the observation at 603, so to say. So here, this is my first data row, but the return can be calculated for the first time only for the second data row, because we don't have a reference. And from 603, the first leg is exactly, the first leg of 604 is exactly what we have at 603. Therefore, we get this now here on a diagonal form, and this value on the other diagonal, and so forth and so forth, up, down, up, down. From this point on, we have, for the first time, we have 6 full legs, if you like. So before, my example was, with 3 legs only. Here I'm going a little bit getting more sophisticated. The machine doesn't really care, my algorithm. And here I'm working now with the 6 ones. And in terms of what I'm trying to do, I'm here have the code that did the visualization that I was showing you before. In terms of, this would be my mid-close price, but I'm not really interested in the level itself. These are my returns, some larger, some smaller, but the red dots, this is what I'm after. I try to predict on a minute basis now whether the market goes up or down. You have seen this, but you have seen this in the slides based on end of day data. Now let me apply the machinery, the machine learning algorithm. Here it's SVM, support vector machines. And you see the whole application of this algorithm is, if you like, 4 lines only. Here I'm importing this from the machine learning library. Here I'm setting up the model. The next step, this is the major one. Here I'm fitting the data, the returns data, my lag data, to the labels, also the returns data. These are the lags. This is what I try to predict. It's also pretty fast. So if you're interested in timing, so for my small data set, this is accomplished by within 8 or let's say 9 milliseconds. And now this is the prediction step. And you see that the prediction values are now 1 or -1, 1 or -1, and changing. So the algorithm says, given the data that I've seen in the first row, I would predict 1, here -1, and so forth. So basically, the algorithm now has some idea, given historical data, whether the market might go up and down. Here illustrated by the red dots. In the meantime, there is a question with regard to Jupyter Notebook. So for the first webinar, I shared everything because everything was already there in open source. At this point, I cannot share the, I can just share a fixed version, which I might do afterwards, and we would share the link. But we cannot share the code so that you can replicate everything that you see. But at least I think we can share a let's say, fixed HTML version, not one that you can execute. There's a question with regard to whether I can explain the math a little bit. I'm sorry, this is well beyond our webinar here, but support vector machines is kind of a standard algorithm which is explained in, let's say, almost every book of machine learning, like Introduction to Statistical Learning or Elements of Statistical Learning, or to this end, some others. For calculating the return, of course, this is something I can do here. This is the single line of code. So I take basically this column and do a vectorized operation. I take the complete column divided by the complete column, shifted by 1 day, and take the logarithm. So here I'm working with log returns. And you see no iteration. No iteration involved. This is kind of the characteristic of vectorized code. And you see how convenient this is. So this line here creates the returns column out of the mid-close one. There's another question with regard to an estimated timeline. I cannot comment on this. I can only say soon, even maybe shortly, but this is not yet official when this will be released. Now let me use my prediction values. Here I have now some predictions out of my algorithm, and I put these into the data frame, multiply my predictions by the returns, and here what you see now is the performance of my algorithm, which is called strategy, green here, versus the blue line, which is the benchmark. So the blue line resembles closely that one in parts or this one here. So this is our base data set, but in absolute values, here we see it in relative performance terms, and you see that the green line is outperforming the baseline, the benchmark investment considerably. But, and this is a big but in capital letters, B-U-T. First of all, this is unleveraged. This is not the issue I want to point you to. And second of all, and this is more important, is that we are working here with mid-close values throughout, and that there is no bid-ask spread or any type of transaction costs involved. So this is a plain vanilla backtesting idea showing that the algorithm can outperform the underlying, but for the time being, not including transaction costs. I won't do this today because it's a little bit more involved, but when we have a look at the positions, we see that we have some 493 days here that we are considering, and 212 out of these days we are long, and 181 we are short. This is not the big question, but the question is here, how often do we change the position? And you see that on 202 days there is no change, but on 190 days we have a trade. So this strategy that we have derived trades kind of frequently, and the more frequently we trade, the more transaction costs, mostly here talking about the FXCM instrument, in the form of bid-ask spread, needs to be accounted for. But this is some topic for probably another context. I just wanted to show you how good the algorithms are in pattern recognition and predicting returns, and what we have been doing here. And the basis for all this, you see it here once again, are the lags, where we use previous returns and only the sign plus or +1 or -1 and try to predict the next day. And this is also machine learning. People would say, well, you just do in sample and no out of sample, or you just do training on the training data set. You don't have a test or validation data set. I'm completely aware of this, and once again, this is just to show how this works and how these perform on a single data set. This, like usual, does not mean that when we now go 2 hours further that the green line will go the same way. For sure not. So many qualifications apply here. I just wanted to show you on a technical level how we can apply machine learning to our problem of predicting market movements. Another technical question, which is kind of nice with regard to red dots and green dots. Actually, it doesn't do red and green. It does here +1 and -1. But I think it's the same thing you're after. So instead of colors, we have here +1 and -1. Plus would be related to your question, would be green, and -1 would be red for down. So this is what the machine does. The machine better understands zeros and ones, or -1s and +1s, than colors in that sense. The next part here is a quick one, a short one. Basically, what I'm showing you here is how to work with streaming data. The first application is simple. So this looks a little bit technical, but be assured this is just a sophisticated print function. So no real algorithm or fundamental stuff behind it. And when I call subscribe market data here, using the callback function, this might take a little while, and now it starts running, and you see in my Jupyter notebook, you see now that I get real-time data. So again, GMT time, and I get real-time data from the socket API. I'm stopping it here now, unsubscribe market data, because this would run forever. It runs asynchronously, and this is now, let me have a look, yeah, 52, 55. So maybe time is a little bit different here, but we are online in the sense that we get the latest data available. Printing out all this might be a little bit boring because we as algorithmic traders, we don't want to read columns of data. I think these days are over. Therefore, I have written a little wrapper for the Plotly library. And what I'm doing here, you see I have embedded an empty canvas, and now the painter will be made ready. Instead of printing out the data, I'm now sometimes it lags a little bit. Should start streaming now. This is always when you want to illustrate or visualize something. Let me maybe try it once again. Subscribe market data, stream data. This should all be running. This is of course now a ad hoc setup. Oh no, I stopped it too early. Here you see there was a little delay in the transmission of the data. So now I've started it again and we are live. This might be due to my internet connection, for example. One of the reasons why I usually recommend, that this is what we teach in our program in detail, how to set up a professional infrastructure. And what you have seen before here as rows and rows of data, 27 rows, we now pick out 2 data streams and visualize them in real time. So the same benefits of what I've pointed out with regard to D3GS and Plotly from before apply here as well. So I can always zoom in. And this is just meant as a very simple illustration of how we can retrieve the data in real time and retrieve the data in real time and visualize it in real time. So here you see it now in my notebook. And once again, typically you would run all such code in the cloud with a much faster internet connection, no interference with the stuff that is running on my machine, like now GoToWebinar or other things that are going on. So and I'm just having a look. Oh, well, just having a look at this. There's another question with regard to the Jupyter Notebook. I said in static fashion I can share it, but it won't work what I show you with FXCM because this is not yet released. And the other question here that is currently asked is what else recommend in this regard. So I can only recommend to get started with what we have covered in the first webinar about tick data and everything. This is all there. And beyond that, it won't take too long until this will be available as a beta release, at least, to a broader audience. So it's not that we are talking about another 12 months or so. It is on the horizon, but I hope you understand that I cannot comment here on the exact dates when it will be available, because there are a few dependencies. But now you see kind of how this is running, and I should stop it now because this will also run forever. Bringing me already to the last part, and just having a look at the question, because between parts it's always good to answer them. I was pretty sure that this question will come. Will you cover such algorithms here and there? The webinar series is not about machine learning algorithms per se. So I will probably use one such example for the next webinar, but we won't teach the application of it in that sense. So here, the algorithm that is mentioned is RNN, recurring neural network. I might use some other algorithm, but there are other resources, and I can only mention once again our own certificate program and training program, where we cover many, many more. But here, the focus, of course, lies on the technology side, on illustrating how to work with the RESTful API, how to make best use of the Python wrapper for the RESTful API, and everything else is just kind of an example and a little bit of background that we provide. So to have it not too dry, so to say, but rather with a little bit of flesh on the bones that we present there. But don't expect it to be kind of a machine learning tutorial, so to say. So here I start with market orders, some standard stuff that you need, like sliced bread for breakfast. And the first thing here is I define my account, the symbol I want to trade, buys to. Here the amount is in thousands, so I would trade quite a bit here, but this is all example. So all the amounts and rates and everything that I'm going to use, this is just to illustrate how it works. So this might not make sense currently from any kind of perspective, might make sense from some perspective, but again, the focus here is on the technology. And I'm executing the trade here. And when I now have a look at open positions, you see I get quite a bunch of information. So this is the value, amount K, you see here thousands, trading quite a bit. You see already my cross P&L here, which is negative, but I did this blind, so to say. You see, I'm just going in, and when I would sell it immediately, I probably would book a loss here. Maybe with a little bit of luck, I would book a profit. You see, we get quite a bunch of information. Here. We can trim it down. So with Python, since this all is a Python data frame object, we can, for example, for us here in such a context, define the columns that we are interested in and use these as a selector. So this is now maybe a little bit better readable. This is the trade ID for this account, the currency, the amount is a long position, and here you see the P&L. This is already a little bit. Where is the visible P&L here, minus 2.7. You see that this changes in real time. Here, there's a question with regard to entry orders, stop orders. I will show this in a second. I won't show all the capabilities because it's a little bit too much. Maybe a few more next time, but I will show more order types after these introductory examples. So this was Euro, US dollar. Now I'm going with the US dollar, Japanese yen. It's also a long position. And we see after that, as expected, we now have two positions because we have opened two trades. So here you see that I'm now using another function, another method of this object, close trade. And I reference now trade number 2, and I'm going to partially close it by 200. So trade 2 here, you see 333. Here I'm closing it by 200. And when I execute this one, you see afterwards that the amount now has been reduced to 133 because I, you see, closed the trade, not completely, but by 200. Now let me add one more trade, Euro, US dollar, and now the difference is, you might have noticed, maybe not, this was a long trade. this as well. So is buy equals true means that we do a real buy here, setting up a long position. And here now, this is a shorting procedure. 222 is the, I'm just using such numbers that we have an easier time to see the differences afterwards. So having executed that one, and what we see now, we need to have this all open. US dollar Japanese yen as before, 133. And here this was 555 and now 333. So this order actually has a similar effect to my close trade. So this gets presented in netted fashion. Now let me execute yet another one. So we are moving on through trades, but again, this is just to show you how this basically works. And we decrease the position furthermore. So you see by another 111. Now we might, at the end of the day, when we have placed multiple trades, multiple orders and whatnot, we might say, well, I want to close all positions for euro US dollar, for example, and this is easily accomplished. Just account ID for symbol is true, and then we define the symbol. And when I execute this, you see that the euro US dollar position is now not there anymore, has vanished because we have closed it all. If we would have had 10 positions in euro US dollar from different trades, then all these positions would have been closed. The same holds true here for US dollar Japanese yen. When I execute this here, see, I get an empty data frame indicating that we don't have any open positions. And when you recall this, this was the first that I did here. So we started with an empty set of open positions, and we end this little illustration in the same fashion. Now there was the question with regard to other orders. I'm not covering here OCO orders or different types, but what I'm covering here are entry orders. Entry orders in the original sense with a target rate, so to say, that is below what we currently see, but also stop orders in the sense that we want to enter if the future rate will be higher at a certain amount that we need to fix than what we observe currently. So let me see the same here, orders. This is an empty data set. Now let me just have a look at the current price. So we have the current price in US dollar Japanese yen is 113.5, we can say. And now I'm going here to place the entry orders. I could, for example, say here, limit at 113.1. This is now from my previous numbers, and the rate that I want to have here is 113. So this is where I want to buy with a limit of 130. So I can execute this. The other one here is now defining a stop. So this is higher than our current rate. So whenever we hit this this level, this could be adjusted as well. Let us say, for example, here 114.1 and this 0.9, for example. I can place this order. And now, looking up the order IDs, I can, with my order here, I can, you see here from the order, this is that one that I just placed, I can look up certain things. So here, get is buy is true, buy 114, you see the rate here, the amount, you see here, it's 222, the currency is US dollar Japanese yen, and here I'm getting all the orders. So now I have two open orders with the numbers that I have placed. And what I've been doing before, I can do here as well. You see there's quite a bunch of information associated with a single order, and I can pick out those columns where I say, well, these are the ones that interest me. So the trade ID, the amount, buy, currency, is buy true, and some limit rate that we might have here. Stop loss, I'm not going to illustrate here so far. So I'm just illustrating entry orders as I'm now showing, as well as stop orders, as well as the market orders previously. Once again, we unfortunately cannot cover everything that the API can do. This is well too much. I can, for example, also adjust orders on the fly. So I can set the amount for the order to, you see here, for my, where is the order ID? There, it's the order ID 3347. And we have the second one. This was the 222. And I can change it here. You see, this was what I was looking for, that one we are talking about, and I can change this to 444. So I can double up if you like, and you see on the fly, my outstanding order has been, I see it here, has been doubled now with regard to the amount. Just creating another order for euro US dollar with different numbers here. As you can see, we now have 3 orders live, and maybe none of your orders during the day, or just a smaller subset, has been executed and say, well, usually at 4 p.m. in the afternoon, I close out everything and I cancel all orders, and this is what is done here. So in this cell, we read out all outstanding, all open orders. And when we now have a look, after we have deleted all the orders, you see that our order list is empty, exactly the same state as when we started. Also a technical question, automatic trading execution based on conditions set by the user. Of course, such a RESTful API with the functionality that I'm describing provides you with some base default functionality. You can, of course, program any kind of execution logic. This is then in the end what the algorithm is about in Python. So this is, from my point of view, and rightly so, not part of the API in that sense, beyond the automated features that I am showing here, but signal generation and order initiations, so to say, should come from the Python end, where the logic is encoded in the form of Python code, in the form of an algorithm that I've trained to data. So this is my take on this question. There's once again a question with regard to the details of REST API calls. All those details, documentation, examples, and so forth, they all will be made public once the API will be released. But so far, I cannot hint you and I cannot point you to any stage, because this is frankly a little bit like whetting the appetite, but you cannot make immediate use of it. But I said it before, watch out, it will come out soon, and then all the functionality will be explained and will be there. Are all lean functionalities available in here? I don't know what is meant by lean functionalities. Maybe this is some related to some specific insights there. Yeah, this brings me already to the end of the live demo, connecting to the FXCM RESTful API. I've seen this is straightforward. Retrieving and working with data is straightforward. While working, of course, it's more like a Python and Pandas thing. Using machine learning, you've seen once we have the data available, my machine learning application boiled down to 4 lines of code, from importing the model to creating predictions, retrieving and visualizing streaming data. If you have a proper, robust, and fast enough interconnection, there's no issue. And if you are not doing any kind of webinar streaming. And lastly, placing orders. You have in principle all the functionality that you're used to from trading on the FXCM platform anyways. So everything is available in a programmatic fashion, and how to combine the single elements into an implemented, automated algorithmic trading strategy. This will be part of the third webinar in this sense. Bringing me to the end, but of course I have a few more minutes more. So if there are more questions, technical ones in particular, I'm more than happy to answer them. And if there are questions with regard to timeline, with regard to FXCM topics, please get in touch with FXCM people. They are also following along, and I know that they are making a great job here in answering all those questions. Oh, the one particular question is related to Quantconnect. I'm not aware of the details there, so I cannot, fortunately, comment on this point. Maybe somebody from FXCM knows a little bit more in this regard. Just going through. Where's there's one of my favorite questions. Where is the best place to learn Python? In general, it's hard to answer. If you want to learn it for algorithmic trading, I must refer you to our own page. So I might share this one link here. You have it in the slides as well. So certificate program, you find further question there as well. There's another technical setup question. It's a good one. I always like to have this. If a machine learning strategy could be run in 1 minute bars in real time on a PC, or if cloud-based is needed, is one of my first recommendations that you should. I know this is a little bit now political, but you should get used to working on a Mac or on a Linux environment if you want to deploy professional code. I'm not saying that it does not work on a PC, but there are some issues, and this is just speaking from experience, that people are having sometimes a hard time setting everything up on a PC and based on Windows. And I can only recommend to use a proper infrastructure, because what do you do if you leave the room and there is an update and your machine reboots, or if there is a breakdown in your internet connection and you are not even able to cancel a trade or to close out the position? So I can only recommend go with an infrastructure, and even a $5 per month cloud infrastructure is already more professional in this sense than your local home PC. There is now a question that I don't want to answer in this context. Using one platform over the other. Of course, we are working here really hard with FXCM to provide a really compelling value proposition for algorithmic traders, and I'm pretty sure that once everything is out, unfortunately it's not yet, so but you have seen how far you can go with what is already there, and when this is out, I'm pretty sure that you will have a hard time to find a more compelling value proposition in this regard with any other platform. So let me put it that way. For heavy machine learning, what are the available resources? Oh, well, I cannot give you an exhaustive list, but this starts with cloud instances that we use, like DigitalOcean. Again, my example, $5. I can maybe go there, where you see if you have demand for huger machines. Here you have small machines, you have specialized droplets that go to 32 dedicated CPUs and 40 gigs of memory. They are costly, but sometimes you just need them for, like, let's say an hour, and an hour it costs just $1. So up until something that you have locally. If you have a big PC, if you have a big Ubuntu machine or a big MacBook, I think you can do, as a retail algorithmic trader, you can accomplish quite a bit. So modern hardware And I just today got my MacBook 12-inch. This has an i7 60 gigs of RAM. This is really fast. So even the smallest machines weighing less than 1 kilogram are as powerful as having an i7 and being pretty fast at these things. So at least for prototyping and getting started, you should be well off with, let's say, a modern notebook even. So, and later on, you see here, it's easy to get the scaling out of the cloud and from the cloud provider that that you choose. Yeah, thank you for all the heads up and thumbs up. Another very interesting question: whether it's important, whether it's possible to integrate economic events in machine learning. This, from my point of view, relates to the question whether, in general, we can include unstructured data. And this is a big yes. Of course, you can work with unstructured data. You can even include Twitter feeds. You can include news feeds. Whenever you have a way to digest this in programmatic fashion, there are Python packages, to stay in our Python world, that allow you to process such things as well. One of the by now famous examples is that immediately after Trump started tweeting as a president and bashing technology companies and other companies, people started, of course, following closely in real time what Trump was tweeting about and created trading signals based on companies that he mentioned. Company mentioned plus sentiment is a positive tweet or a negative tweet, then leads to a signal. This is easily accomplished. When I'm saying easily, I mean technically easily. So of course, this means this needs to be done. But by easily, I mean all the ingredients that are needed for such an effort are available and are available for free if you have access to the data source. Which programming language is mostly used in the finance field? So fortunately, I can say we started out using Python more than 10 years ago for finance, and we were kind of like unicorns back then. Now it's one of the most widely used and most important technology platforms in our industry. So of course, there are other languages that are used for quant stuff, like still MATLAB or R, for example. But Python has taken over, and I recently have given a talk why Python has taken over finance, and I think this is true. It's not only data science. As of today, Python is the most important data science language. It's becoming one of the most important ones in the AI field, if not already the most important one. And I'm pretty sure that Python is, as of now, the dominating language overall across different subfields and departments, so to say, in our finance field. Yeah, there's a specific question. Our program covers indeed machine learning and neural networks. So we use TensorFlow with deep neural network classifiers to create signals. So this is what we cover indeed. There's another question of somebody who wants to put AI into practice. Once again, I think you should pick a project. You should use the Python packages available, and you should simply get started. Define your project, the project scope, and collect the tools and the packages as you go. This is what I recommend to many people in this regard. There's somebody sharing a link to learn Python. Yeah, there are many places where you can learn Python. Another question with regard to our certificate training. This can be joined at any time, but the next start will probably be on the beginning of February or end of January next year. There is one comment with regard to whether calculations are done on FXCM part. If this relates to the strategy, I would say no, this is not the case. So you're supposed to run this on your own, like you need your fingers if you want to do day trading. Many people have thanked me for the webinar, so I can only say my pleasure, and I'm pretty sure that's also the pleasure of the FXCM team, who is working hard in the background to set everything up and to make this all available. So a big thank you to the FXCM team there as well. And yeah, I think we are through the questions here. For me, it remains to say happy Python coding and particular successful algorithmic trading, and see you in the third webinar. Take care. Bye-bye.